Greetings from Mobility Outlook and welcome to Mobility Conversations. Today we are at the India headquarters of Detroit Engineered Products, and our guest for today is Mr. Radha Krishnan, President and Founder, Detroit Engineered Products. Mr. Radha Krishnan, welcome to the show.
Good morning.
Morning.
Thank you.
Okay. So there are a lot of things happening in the CE industry. What is the current trend? If you can brief about the influences that affect CE.
Sure. As you are probably aware, CAE, or alternately we'll call it as virtual engineering, that has become de facto the actual engineering. And there's a lot of important developments happening in this CAE field. Especially whether it is a mobility industry like automotive or aerospace, etc., the electrification has become the new trend on the product side. So CAE is rapidly adapting to address the electrification challenges. So new methods need to be developed to design and analyze a battery or an electric motor, etc. So the application could be both an automotive or an aircraft. So rapidly the electrification is changing the nature of CAE.
Okay.
So this is what I feel is the major new thing that is happening with respect to CAE.
How was simulation per se growing over the last decade?
Tremendously. I would say if you take a large automotive company like a GM, Toyota, etc., at one point of time, rewinding back 20 years ago, the number of physical prototypes that they would create before they bring out a new product to the market would be 3 physical prototype stages. These days, almost it's come down to only 1 physical prototype. Rest of it is all virtual. Okay. So which means CAE is playing a very dominant role in taking the lion's share of engineering, the simulation-based engineering. Okay. So that trend is only further and further accelerating, I should say.
Okay. Detroit Engineering per se has a couple of verticals. One is the engineering services and another is the MeshWorks.
Correct.
What's the update on the engineering services?
On the design and engineering services, DEP, or Detroit Engineered Products, we started off as a core CAE company way back in 1998 in Michigan, Detroit, Michigan. But over the last 25 years, we have added several other disciplines to design and engineering, starting all the way from ideation, product ideation, then systems engineering, design, which is a CAD, tolerance stack-up, GD&T, etc. Then CAE, of course, and then also prototyping. All right, prototyping and testing. Okay. So today we have grown to an organization where the customer can come with an initial idea and walk away with a working prototype. So we do all the 9 yards in between from ideation to a final prototype delivery.
Okay.
Yeah.
Very interesting to know that it is actually squeezing in the development time.
Correct.
Yeah.
Correct.
What about MeshWorks? I think you are software for simulation.
Yes, there are quite a few fine design, development and engineering companies worldwide, but there's one thing unique about DEP, which is MeshWorks. It is our own product, our own software suite. It is a CAE platform which will allow engineers, CAE engineers, to design and build their finite element models, CFD models, etc., which are core models necessary for virtual engineering in a much shorter time frame compared to other products in the market. But more importantly, MeshWorks has the capability to guide the simulation at the very early stages of the product development, when there is no CAD whatsoever available.
Okay.
With zero CAD, you can still create your concept finite element models with morphing technologies, our ConceptWorks technology, and you can do your simulation-based engineering at the very early stages of the product design and development time itself. And of course, subsequently, you can optimize your designs for lightweighting, reduced loads, etc. with our MeshWorks platform.
But some of your customers, whether OEs or the component manufacturers, they experience a lot of challenges even in simulation. What are the challenges, typical challenges, and then how DEP helps them mitigate those challenges?
Okay, so if you talk specifically about the latest trend of electrification, okay, one of the main challenges faced by most customers is the simulation capability of new components like a battery, the electrochemical simulation of a battery, or a thermal runaway problem simulation of a battery, or there is an electric motor. How do you simulate it for electromagnetism to get the torque performance characteristics, torque speed performance characteristics to your target requirement? All this calls for a lot of new methods development. So that is one major challenge faced by the industry. And another major challenge is the time to market. As you know, on the business side, the barrier to bring an EV to the market is much lesser compared to conventional ICE engines. So the industry folks, whether it's OEs or Tier 1 suppliers, want to bring their products to the market much quicker to the market. So these are a couple of major challenges we feel. And always there is the product optimization to maximize the range, especially for electric vehicles, whether it's two-wheelers, three-wheelers or four-wheelers, and still be within the cost target. That is yet another unique challenge faced by the industry.
Oh, I see. Okay. Can you explain to me with how Detroit Engineered Products helped an OEM or a supplier to reduce the time to market?
We have three major pillars in our solution to the OEs as well as Tier 1 suppliers, especially in the electrification area. The first pillar is our technology. Within our MeshWorks platform, we have a unique module called eMod.
Okay.
It's called the electrification module.
Okay.
It is a collection of all modeling tools meant for modeling batteries, electric motors, electric vehicle platforms, etc. So that is one aspect of it. A second aspect of it is all the simulation workflows.
Okay.
How to do a complete thermal and durability simulation of an electric motor, etc. Or a high frequency noise, how to predict it coming out of an electric motor, or a battery thermal runaway simulation, etc. These are all ready to use simulation workflow that is available in the eMod, which means customers need not have to learn anything new. It's ready to use. And another important solution we have is a digital twin electric skateboard, EV skateboard. So the physical skateboards have been around for some time, maybe last 5 years or so. There are different different OEs developing and selling the physical skateboards. What we have come up with is a unique digital twin skateboard.
Okay.
So if a new startup electric vehicle company wants to develop their platform or vehicle, they can right away adopt our digital twin and be quick to the market And it's a flexible architecture. You can come up with different wheelbases, different overhangs, etc. All the design and engineering has been pre-created or done already with this skateboard.
Okay.
And then the third pillar of our solution is our design and engineering. We being in the industry for quite some time, we know how to develop an electric vehicle, whether it's a two-wheeler, three-wheeler or four-wheeler, all the way from a systems engineering to component engineering using what we call as the classic V-cycle development process.
Okay.
Our team has the full range of capabilities.
Okay.
So using these three pillars, we believe we have a unique proposition for our customers.
Yeah, talking about the second pillar, how can the customers create their uniqueness while they use a modular virtual skateboard?
Great question, great question. The skateboard is more like a foundation. It is the underbody of the vehicle. So when you sell your end product to a customer, the customer doesn't get to see as much what is in the chassis or the underbody. The customer cares for the upper body, the upper shell, and the value or the experience the upper body brings to the end user. So keeping that in mind, our morphing technologies will help the EV maker to slap on different upper bodies to a skateboard. So for example, a same skateboard can be used to create a passenger car or a multi-purpose vehicle or a utility truck. So the EV maker can slap on different upper bodies, and they can also use our morphing technologies to quickly morph the upper body for different styles, thereby reducing the time for the upper body development as well. So the advantage is marrying different upper bodies to a ready-to-use EV skateboard. So this is the way you can really cut down the time to market. The development time can be significantly cut down. We believe literally 1 year of development time on a 3-year development cycle can be cut down thanks to this unique skateboard come morphable upper body philosophy. Right.
Can they also play around the standardization and benefit out of the economies of scale?
Yes. To be honest, that is something we have to wait and see. The economies of scale is more on the production side.
Correct.
We play more in the design and development side. So here on the design and engineering side, the economies of scale could be thought of more like how can I do an engineering which can simultaneously spin off a sedan, a sporty vehicle, as well as a multi-purpose vehicle. So that kind of scalability naturally comes with our design and development approach.
No. My question was primarily on when they productionize with the morphing technology, they have the base, which is modular. That can help them in standardizing the parts and components or whatever elements that goes into the skateboard, which will help them in economies of scale.
You're absolutely right. Maybe I misunderstood your question earlier. On the production side, by making it modular, there are several parts of the EV which can be made common and hence produced in much larger scale, and that common parts could cater to both a sporty vehicle as well as a multi-purpose vehicle. And then there will be a small percentage of customized parts for each different platform. So this kind of modularity naturally brings you the economies of scale. You're absolutely right.
When it comes to EVs, there are different modules vehicle manufacturers are focusing on. Battery, like you said, and also motors. In motors, I think there are new technologies are coming, like for example, reluctance motor, magnetless, for many reasons. Obviously for many reasons, because sourcing, etc. How Detroit engineered products can help them adapt these new technologies faster in their developing phase?
Okay, that's a great question, and it's a little bit in depth also. We go down to the fundamentals of electromagnetism. This means how to position the permanent magnets in a rotor. Should it be a V configuration, or it could be a different configuration? All that directly impacts the performance and efficiency of the motor. Okay. So in order to optimize and get the best performance and also the power density of the motor, all these different design parameters of the rotor and stator needs to be played around with in context of the electromagnetism principles. This is where the virtual simulation gives us the ability to quickly try out different configurations until we get an optimized motor design.
Okay.
So this is one thing. Then if you look at on the controls side, once you have a motor designed, there are a lot of soft knobs you can tune, controlling the current that is flowing into the motor and the phasing of it, the magnitude of it, etc. So you can make the same motor operate at its peak efficiency, whether it is at a low speed situation or at a high speed situation, at different operating regimes through smart controls.
Okay.
You can make the motor operate at the same efficiency across the operating regime. All this calls for smart controls engineering. So both at a design level as well as at a subsequent controls engineering level, there is a lot of flexibility you get in getting an optimized product.
Okay.
Yeah.
So Detroit engineered products has been catering to customers in different segments, like for example ICE, internal combustion engine hauled vehicles, and also electric. What are the new opportunities that you see?
Okay. We look at passenger car segment as well as commercial vehicles. In the passenger car segment, of course, electrification is going to be there, and that the trend is only going to further accelerate. With respect to the commercial vehicles, today at DEP we are working on hydrogen-based internal combustion engine.
I see.
So we already are already working on few programs in North America, supporting our customers in doing advanced combustion using hydrogen as the fuel, and we have developed our own combustion sensing technologies with which you can control the combustion every crank cycle.
Oh.
So we have that ability now, and this particular sensing technology is a key enabler for advanced combustion like hydrogen combustion. So on the heavy duty side, the hydrogen ICE is something DEP is working on as we speak. And we also have some aerospace customers,
Okay.
Where we have the opportunity now to work on electrified aircrafts, personal mobility aircrafts, the eVTOL, they call it as electric vertical takeoff and landing kind of aircrafts. So we have some opportunities that we are working on in that sphere as well.
Yeah. Interesting to know about the hydrogen. For vehicle manufacturers, which one do you think will be easier for them to adapt to hydrogen technology? Hydrogen ICE or fuel cells?
There is a lot of debate going on. If I were to take a personal bet on, I believe the hydrogen internal combustion engine has a better possibility of getting into mass production. Obviously, there's a cost advantage. There is an existing infrastructure of ICE engine. We need to only do an adaptation of that to hydrogen. Fuel cell is obviously a new technology. It's more expensive and it calls for much higher purity of the hydrogen. So which comes with its own cost. Whereas the hydrogen ICE probably may not require that kind of a purity. So still the debate is going on. Most companies, I believe, are putting their eggs in multiple baskets.
Okay.
Yeah.
Okay. I think you are present in 8 locations across the globe. What are the uniqueness of these locations? Are there any symbiotic relationship amongst them to cater to different markets in the world?
Yes, this is another very important question with respect to how, as a business, we are set up. We have offices in Europe, US, Japan, Korea, India and China. These are all major geographies where we have our offices. All the advanced technology development almost always happens in our US location.
Okay.
So that is where, whether it's a simulation technology, the software algorithm generation, or for that matter, right now we are working on level 3 plus level 4 autonomous driving features, etc. These are all typically initiated and originated in our US facility and to some extent in our Japan and Europe facilities as well. But then operationally, since we are an engineering, design and development company supporting various customers, we have what is called an HCC LCC business model. HCC stands for high cost center and LCC low cost center. So naturally the India operation is treated as a low cost center. So we have a symbiotic relationship wherein for any customer engagement there is a certain content coming from our US geography or Europe geography, like a typical 20% for instance, or an 80% content coming from our India geography.
Okay.
So it's a good marriage between a high technology and an operational cost efficiency from our India geography, and that way giving the best value to our customer. So customers are able to get access to our advanced technology like the eMod that I was talking about on the one hand, and at the same time they get a cost advantage with this HCC LCC model.
Okay.
Yeah.
Okay.
Yeah.
So what are your plans for the company for the next 5 years?
We have big plans. We are quite gung-ho about the growth prospects for DEP, whether it is our engineering services or our software, MeshWorks software. In both cases, we are seeing quite a bit of upward potential for growth. So over the next 3 years, we have our business plan set where we are going to be pretty much 3 times the size what we are today. That's a fairly aggressive growth target that we have set. but we have enabled it with all the appropriate investments to support that kind of a growth.
Okay.
Yeah.
Great. That's interesting. Radha Krishnan, thank you so much for sparing your valuable time.
Thank you so much.
Thank you so much. Thank you.
Thank you.